Assalamualaikum and good morning everyone. So today I'm going to discuss about cofactors. Okay, now cofactors, okay, some enzyme can function on its own without cofactors. So cofactors relatively is a chemical component, okay, it's a non-protein component of an enzyme that assists the function of the enzymes. Okay, now some enzymes, all right, without this cofactor, these enzymes are inactive, meaning to say that enzyme is a bit sort of like useless. Okay, and particularly many enzymes contains cofactors. Okay, so enzyme when this enzyme, all right, or also known as apoenzyme, without its cofactor, an enzyme that is without its coenzyme, that enzyme is known as apoenzyme. Okay, now this apoenzyme, when this apoenzyme bind with its coenzyme, okay, these two components will make up a holoenzyme. All right, and a holoenzyme is an active enzyme, and apoenzyme is an inactive enzyme. Okay, now there are three groups of cofactors here, okay, that we are going to discuss, and they are the coenzymes, prostatic groups, and metal ions. Okay, and a complete enzyme with its cofactor is known as the holoenzyme, like what I've mentioned earlier. Okay, and the protein part of an enzyme is known as apoenzyme, and an apoenzyme is an inactive enzyme. So to sum things up, apoenzyme with cofactors, okay, known as the holoenzyme. Okay, now let's take a look at coenzyme. Okay, so coenzymes, they are small non-protein organic substance, okay, that temporarily or loosely bind to the active sites of the enzyme. Okay, class, so you need to know the characteristic of this coenzyme. Okay, so coenzyme bind loosely to the active site of the apoenzyme or to the enzyme. Okay, but to be more specific is the apoenzyme. And then this coenzyme forms weak hydrogen bonds with the enzyme, okay, and weaken the bonds of the substrate. Coenzyme, since this coenzyme bind loosely to the active site of the enzyme, so coenzyme can be separated from the enzyme and reusable, okay, or readily detached. Coenzyme is readily detached from the enzyme and reusable. Then this coenzyme make up part of the active site. Yes, obviously, because this coenzyme, it binds loosely to the active site of the enzyme, so coenzyme make up part of the active site of the enzyme. And without the coenzyme, right, since coenzyme is a cofactor, right, so without this coenzyme, the enzyme would not function, or inactive enzyme. You can see from this diagram here how this coenzyme bind to the active sites of the apoenzyme. All right, after binded, then the enzyme is an active enzyme and can catalyze chemical reaction with substrates. Okay, now vitamin C is one example of coenzyme, okay, and vitamin B acts as coenzymes or raw materials from which coenzymes are made, okay, to produce coenzyme. Okay, ini if we rewrite the sentence, acts as coenzymes or raw materials from which coenzymes are made or produced. Made, I think made is enough. Okay, yes, so meaning to say, okay, vitamin C is a coenzyme, right, And vitamin B, it can act as coenzymes or as raw materials to synthesize coenzymes. Okay. Now, example here is vitamin B3 or niacin. Okay, niacin is needed, okay, to synthesize NAD. Okay, NAD plus or nicotinamide adenine dinucleotide. Okay, you learn about this in detail later in the respiration chapter. Okay, and the function of this NAD plus is for oxidation or for hydrogen acceptor or hydrogen transfer. Okay, and then B2, vitamin B2 or riboflavin, okay, is needed, okay, to synthesize the flavin adenine dinucleotide or FAD. And this FAD function the same as the NAD plus for oxidation or for hydrogen acceptor or hydrogen transfer. Okay, pantotonic acid or B5, right? This B5 vitamin, okay, is needed to synthesize the coenzyme A. And then this coenzyme A is needed as the acetyl group carrier. You learn about this coenzyme A in detail later in the respiration chapter. Okay, while for vitamin B12, okay, this B12, apparently this vitamin B12 on its own, okay, it acts as coenzyme B12, okay, and function in the methyl group transfer. Okay, you learn about this in detail again in the respiration chapter. Now, next, prostatic group, which is another type of cofactor. Okay, remember there are three types of cofactor. Okay, coenzymes, prostatic group, and metal ions. Now, prostatic group, these are non-protein organic molecule, okay, that binds tightly or permanently to the enzyme. So this is a bit different if compared with the coenzyme. Coenzyme binds loosely, whereas for this prostatic group, this non-protein organic molecule binds tightly or permanently to the enzyme. Okay, you can see from this diagram how this prostatic group bind to this apoenzyme permanently. Okay, then this holoenzyme, which is an active enzyme, can function, right, which is to break down the substrate into products. Now, prostatic group, right, cannot be separated from the enzyme. Okay, and then the enzyme is inactive without the prostatic group. Now, example of prostatic group, all right, is heme. Okay, heme is a prostatic group in the enzyme catalase. Okay, so this catalase enzyme apparently, okay, catalyze the decomposition or breakdown of hydrogen peroxide into oxygen and water. Okay, and heme, okay, also can act as prostatic group in cytochrome oxidase, right, which is involved in the cellular respiration, where the enzyme, okay, that permanently bind with the heme transfer hydrogen to oxygen to form water. Right? Now, the third type of cofactor, which is the metal ions. Okay, these metal ions apparently they are also known as the activators. Okay, so activators are inorganic metal ions. Isn't that obvious? Since activators are also known as metal ions. So these activators are inorganic metal ions that binds tightly or loosely to the enzyme. So tightly or loosely. Okay, and you can see from here how this metal ion binds this enzyme, okay, to make this enzyme more capable. All right, meaning to say to increase the velocity of the reaction that is catalyzed by that enzyme. Now, in the enzyme substrate complex, metal ions make the substrate molecule bond less stable and easier to break by drawing the electrons away from the substrate molecules. Okay, so kuat juga metal ion ni. Dia boleh draw with the electron, okay, the substrate molecule punya electron jauh daripada substrate itu. So when these substrate electrons are being drawn away from the substrate molecules, what happens to the substrate molecules? Obviously, the substrate molecule will easier to break down into substrates. Now, metal ions that binds onto the active site of an enzyme will modify the enzyme active site, okay, to be more stable for a reaction to take place, okay, to be more suitable. Okay, biasalah typo error ni kadang-kadang. Okay, now metal ions, okay, binds to enzyme with weak ionic bonds and can be separated from the enzyme, okay, and metal ions helps enzyme to function faster, thus increases the rate of reaction. Okay, now examples of metal ions, right, are calcium ions that is needed to activate thrombokinase that converts prothrombin to thrombin in the blood clotting process, right? Other than that, calcium ions binds to amylase to increase the breakdown of starch to maltose. So now you know why calcium are needed in your diet. Okay, now other metal ions that is that able to bind to the enzyme to increase the enzyme's productivity, all right, are in this list. So we have zinc, magnesium, nickel, molybdenum, okay, and then Fe is selenium, is it? Then we have manganese, and then we have potassium, right? And these are the enzymes. And teacher, do I need to memorize this? No need. Tak payah. Okay, what you need to know is the characteristic of these metal ions, that it can bind tightly or loosely to enzyme, okay, and then how these metal ions draw the electrons away from the substrate, which in turn cause the substrate molecules to be less stable and easier to break down. Okay, all right, so that's it for today. Okay, next lesson will be on inhibitors.